Welcome to AI Frontiers. Today we explore the collective mind of artificial intelligence through 24 groundbreaking research papers published on October 3, 2025. This snapshot reveals AI's collaborative revolution, from multi-agent systems to mathematical verification methods, showcasing emergent capabilities that are transforming machine intelligence. This presentation navigates today's AI research landscape through 24 papers from a single day of publication. The journey will explore 5 dominant themes shaping the field, provide deep dives into 3 seminal research breakthroughs, examine emerging challenges and future directions, and invite participation in the conversation about AI's evolving capabilities. Computer science artificial intelligence represents the field focused on creating machines with intelligent behavior. This encompasses systems capable of perception, learning, and reasoning that extend beyond simple automation to augment human capability and creativity. The field tackles complex scientific and industrial workflows through natural language interaction and decision-making under uncertainty, with the fundamental mission of pushing the boundaries of machine intelligence. Multi-agent and collaborative systems represent a major research theme, moving from solo virtuoso to symphony orchestra approaches. The CoDA system employs specialized agents for data visualization tasks, while the AutoMaAS framework automatically evolves optimal team architectures. Large language model-powered agents coordinate in shared virtual environments, demonstrating how teams of AI specialists outperform monolithic models. This ecosystem approach replaces the single do-it-all AI paradigm. Reasoning, verification, and trust constitute another critical theme, focusing on mathematical guarantees for AI reliability. Research includes bridging large language model planning with formal verification methods and the NCV approach for node-wise consistency verification that enables precise error localization. Policy-compliant agents learn efficient safety guardrails, while natural language plans are converted to formal logic statements, allowing model checking to provide mathematical certainty for AI-generated plans. Generation and diffusion models represent a third major theme, breaking sequential generation bottlenecks. The OneFlow paper introduces the first non-autoregressive multimodal generation model, enabling concurrent text and image generation that mimics human creativity. Coevolutionary continuous discrete diffusion approaches language generation, while Mask GRPO optimizes diffusion models with reinforcement learning, applying continuous diffusion techniques to discrete text data challenges. Key findings across the research papers reveal groundbreaking insights. OneFlow enables concurrent mixed-modal generation breakthroughs, while models consistently fail at self-recognition tasks. The ARMS framework achieves 90% attack success rates on vision language models. Multi-agent systems demonstrate superior problem decomposition capabilities, and formal verification approaches successfully bridge neural and symbolic artificial intelligence methods. Methodology synthesis reveals the technical approaches driving today's AI advances. Multi-agent frameworks employ specialized agents for complex tasks, while diffusion models enable non-autoregressive generation for better global coherence. Formal verification provides mathematical guarantees using logic methods. Reinforcement learning optimizes models through reward signals, and architecture search enables automated discovery of optimal AI system configurations. The selected paper by Nguyen and colleagues, titled OneFlow, introduces concurrent, mixed-modal, and interleaved generation with edit flows. This work breaks the sequential generation constraint in multimodal artificial intelligence by combining insertion-based edit flow for text with flow matching for images. The system enables simultaneous text and image generation that resembles human creativity, uses 50% fewer training computations than sequential models, and unlocks iterative refinement and more natural reasoning processes. The selected paper by Ramani and team addresses bridging large language model planning agents and formal methods. This research converts natural language plans to formal logic representations, using crypt key structures and linear temporal logic for verification. GPT-5 achieves 96% F1 score on plan correctness classification, providing mathematical certainty for AI-generated plans and addressing the critical trust gap in autonomous system deployment. The selected paper by Bai and collaborators, titled Know Thyself, examines the incapability and implications of AI self-recognition. A systematic evaluation of 10 contemporary large language models on self-recognition tasks reveals models perform barely above random chance at identifying their own generated text. The research reveals hierarchical bias toward popular model families, challenges claims of meaningful AI self-awareness, and has profound implications for safety and evaluation frameworks. Future research directions indicate where AI research is heading next. Efficient concurrent architectures following OneFlow's lead will be developed, alongside deep fusion of neural and symbolic reasoning approaches. Self-organizing multi-agent ecosystems will tackle complex problems, while automated architecture search enables dynamic problem-solving. Addressing fundamental metacognitive capability gaps remains a critical research priority. This presentation was created through an AI synthesis and review process. Content was synthesized using the GPT DeepSeek-chat model with text-to-speech processing via deepgram TTS synthesis. Visual design concepts utilized stable diffusion image generation. Human experts reviewed all synthesized content for accuracy, though potential oversights may exist despite rigorous review processes. Subscribe to AI Frontiers to stay updated on cutting-edge AI research. Join our YouTube channel for the latest insights and participate in conversations about emerging AI capabilities. Explore weekly research summaries and deep dives while connecting with the AI research community and experts. Become part of shaping the future of artificial intelligence through ongoing engagement with frontier developments. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.